So if you're in the AI space, you are hearing two terms everywhere, Agentic AI and RAG. But what's the deal? Are they competing ideas? Are they partners? Well, in this explainer, we're going to cut right through the noise and show you what they are, how they're different, and honestly, why putting them together might just be the future of building really smart AI.
And you can kind of see why people think this, right? We see these mind-blowing demos of AI writing code and think, okay, so that's what agentic AI is for. Or we hear that RAG connects AI to new information, and we figure, great, that's the magic fix for everything. But the real story? Oh, it's so much more interesting and way more powerful than that. So, which is it? Is agentic AI just for coding? Is RAG always the answer? This is where we have to pull out that classic, maybe slightly annoying consultant's answer. It depends. But hey, don't click away, we're not going to leave you hanging. Over the next few minutes, we're going to show you exactly what it depends on. So here's the game plan. First, we're going to get our terms straight, no more buzzwords. Then we'll actually meet these AI agents and figure out what makes them tick. After that, we'll see how RAG tries to fix their biggest weakness. But then we'll uncover a huge problem with that approach and engineer a much smarter solution, which finally leads us to what really looks like the winning combination. Okay, let's kick things off. Before we can really get into how these things fit together, we've got to strip away all the marketing hype and build a really solid foundation for what agentic AI and RAG actually are. So let's dive right in and meet the AI agents. You know, that word agent gets thrown around constantly, but what does it really mean for an AI to be agentic? What's the secret sauce? Okay, think of it like this. An agentic AI is not just a chatbot waiting for you to type something. Nope, it's an active system. It can actually perceive its digital world, think about what to do next, and then execute actions to get to a specific goal, pretty much on its own. It's the massive leap from a simple calculator to a self-driving car. And these agentic systems are always working, stuck in this constant loop. First, they perceive what's going on. Then they reason about it, maybe checking their memory. Then they act. And after they act, they observe what happened, which feeds right back into the top of the loop. Perceive, reason, act, observe. Over and over again. Now here's where it gets really cool. You can have a whole team of these agents working together. A fantastic way to picture this is like a small software development team. You could have one agent that's the architect, planning everything out. Another is the implementer that actually writes the code. And a third agent is the reviewer, double-checking all the work. And this is so important. This does not mean humans are out of a job. Not at all. It just changes the game for us. Our role gets elevated. We're no longer the musician playing one instrument in the orchestra. We become the conductor, guiding all of these powerful sections to create something amazing. Okay, this all sounds incredible, right? But there's a huge catch. Agents are awesome at thinking and acting. But what happens if their knowledge is just wrong or out of date? Well, they can hallucinate. They'll state something with 100% confidence that's completely made up, and that can lead to actions that aren't just unhelpful but could be seriously bad. And that leads to the million-dollar question. How do we keep these powerful action-taking agents tethered to the real world, to actual facts? And the most common answer you'll hear today is RAG, Retrieval Augmented Generation. The easiest way to think about it is like giving your AI agent a private, fact-checked library that it has to read from before it's allowed to say or do anything. It's an external brain that keeps it honest. Now, RAG basically works in two big phases. The first part is called ingestion, and it happens behind the scenes. You take all your knowledge, PDFs, documents, whatever, and feed it to the system. It chops them up into smaller pieces, and then, here's the magic, it turns the meaning of each piece into a set of numbers, called a vector embedding. It's like giving every single idea its own unique coordinate on a massive map of meaning, and all that gets stored in a special database. Then, when you're actually using it, phase 2 kicks in, online retrieval. You ask a question, your question also gets turned into a vector embedding. The system then uses those coordinates to find the most relevant chunks of info from that map of meaning we just built. It grabs, say, the top 3 to 5 most relevant facts and hands them, along with your question, directly to the AI model. This forces the model to build its answer using your verified data, not just whatever it feels like making up. So that sounds perfect, problem solved. But here's the twist. What happens when you think more data is better and just start dumping everything you have into the system?
Well, that is exactly when a simple RAG setup can start to break down.
This chart shows you the problem perfectly. As you give the AI more retrieved documents, its accuracy goes up, but only to a certain point. See that sweet spot? If you go past that and give it too much information, you just overwhelm it with noise. It's like trying to find a needle in a haystack by adding more hay. The performance actually gets worse.
So why does this happen? Well, for one, the language model has a harder time finding the really important bits in a giant wall of text. It also drives up your costs because you're processing more data. It makes the user wait longer for an answer. And ultimately, all that noise and repetition just makes the final answer worse. It's a textbook case of where more is definitely not better.
So what's the solution? We have to evolve. We need to go from just dumb data dumping to a much more intelligent, intentional way of doing things. Some people are calling this context engineering. So on the left, you've got that basic, naive RAG. On the right, you have a much smarter setup. This uses some really cool advanced techniques, like hybrid recall, which combines that meaning-based search with old-school keyword search, which is actually great for finding specific product codes or names. And then there's re-ranking, which is like a final quality check that puts the absolute best, most relevant piece of info right at the very top. The whole point of all these fancy techniques is to create one single, clean, and perfectly prioritized package of information to give to the AI. And when you do that, you get higher accuracy, you get faster answers, and, you guessed it, it costs less. It's all about working smart, not just working big. Which brings us to our grand finale. We've met our action-taking agents, we've built them a super smart memory with an advanced RAG system, so now let's put all the pieces together and see what this powerful combination actually looks like in action. Oh, and here's a quick pro tip for anyone actually building this stuff. You don't always have to use the big, expensive, proprietary models. Using local open source models can give you way more control over your costs, and it means your sensitive data never has to leave your own systems. That's a huge win for data privacy. So, there you have it. That's the formula. You take an autonomous AI agent that can think and act, but you ground it in reality with a smart, carefully engineered RAG system. This isn't just buzzwords anymore. This is a real blueprint for building AI that is both powerful and trustworthy. It's definitely a winning combination, but like we said right at the start, the best solution always depends. So the real question we want to leave you with is this. Now that you know the building blocks, what will your winning combination depend on?